Hello and welcome to this video. Today I will analyze and classify the code for storing the project in details, focusing on the how improve the performance of the models during the data proportions and the model buildings purchase. Spring has how to evaluate and improve the fit of the models. The whole process is roundly divided into the three parts: data processing, and processing categorical imbalance, model concentrations, and evaluate. Below, I want to through the each step by step and answer to key questions. First, we will read the train data and test the data through pandas and remove the ID columns that's not helpful for predict. Next, in order of the machine learning models to predict the data, we encode all class variables such as genders, even married, work type, residence type, and the smoking status. Using labels encoders, the purpose of this is convergence test categorical to numerical type sets easily of the models to understand and processes. Improve performance, removing the involvement features, reduce noise and the coding's insurance data consistence. Allow the models to convert faster and more accurately. This is the first step in improve the performance of our classifiers. And for the dealing with chemical balance, in this case, the sample size storage is relatively small, while the sample size is non-storical is large. This is categorical imbalance and cause the models to fear the categorical with the majority, thus affecting the model's performance on the few categoricals. Service programs we use under sampling methods. We took all historical samples, military classes, and randomly sampled three times as many data as military class for the non-historical samples in majority class. These two parts of the data are combined to form a balanced data set so that models can pay more attention to storage samples during the training and improve the recognition's ability to positive examples. So for the key points to improve the performance, dealing with class imbalance by understanding on the samplings, we ensure that the model is not determined by the large numbers of negative samples when the trainings, which is accuracy of the optimize the F1 score boost. And also this second part is about the model concentrations and evaluations. This code, we choose random forces classifiers as our classification models and set up patterns in an estimate equal to 100 and class weight balance. And the class weight balance per variable is automatic to adjust the weight of each category codes against to help the models focus on the less frequency historical categoricals. Next, we use starting force of 50% cross validations. And about the cross validation strategies, adopting the statistical force ensures that the distributions of each trait of the class is consistent with the whole, resulting in more stable and reliable performance valuations. We use closed VL scores to calculate F1 squares of each float and output scores of each float and average scores. The F1 score is particularly suitable for the balanced data because it combines accuracy and recall rates to the more accurately reflected how well the models identify storage samples. So through processing the validations, we can observe the performance of the models on the different subsets. In F1 scores of each discard are not different. It indicates that models is well fit and have certificate generations abilities. Otherwise, further turn on other balance technology may be need to improve the models. After completing the cross validations evaluations, we even train the models on the entire balance data set model predictions on the test data. ultimately saving the predictions to CSV files. Measures to improve classifiers performance. Data processes reward the invariance features such as IDs and encode categorical variables to ensure the data consistency. Dealing the categorical imbalance understanding the methods is adapted to make the ratios positive and negative samples more reasonable so as improve recognition rates is models for the few categoricals like the story. And the model set, what we do is select a random forces and further adjust in class weights by the class weights equal to balance and to reduce the negative impact for the imbalance of the models. Overall, we use cross validations, perform 5-fold cross validations with spherical 30-fold, ensure that chemical distributions of each float is consistent with overall data. And the evaluate index selections, F1 scores is used as an evaluation index, which is can better reflect the pros and consists of the models that simple accurate when the dealing with imbalanced problems. Observe the cross validations results output scores per break and the average F1 to evaluate the stabilities to generalizations and abilities of the models, provide the basis of the possible subqueries hyperpyramid turnings. Summarize code, we not only improve the model performance through the refining and the process and class balance, but also to use cross validations to optimize the evaluate the models and generate abilities. These two aspects of the workers ensure that the models in both evaluate and accurate the predict score risk. And thank you for watching, and I hope today's shares will help you to in building and optimize the classifiers. Do you have any questions? Let me know. Thank you.